solve in positive integers this equation. By rearranging the equation, we have x cubed plus y cubed equals 6 times 2022 times root of xy minus 4, since 4 divides 6 times 2022. So 4 must divide x cubed plus y cubed. Thus, both x and y are even. Let x equal to u, y equal to v. U, v are positive integers. Equation 1 can be written as 2u all cubed plus 2v all cubed equals 6 times 2022 times root of 2u times 2v minus 4. By simplifying the equation, we have 8u cubed plus 8v cubed equals 6 times 2022 times root of 4uv minus 4. 8u cubed plus 8v cubed can be written as 8 times u cubed plus v cubed root of 4uv minus 4 can be written as 2 times root of uv minus 1. Now we divide both sides of the equation by 8. We have u cubed plus v cubed equals 9 times 337 times root of uv minus 1. Since u, v are positive integers, so uv minus 1 must be a perfect square. Let uv minus 1 equal t squared, u plus v equal s. T, s are positive integers. We know that u plus v equals s, so u plus v all cubed equals s cubed. By expanding the left-hand side of the equation, we have u cubed plus 3u squared v plus 3uv squared plus v cubed. By factorizing 3u squared v plus 3uv squared, we have 3uv times u plus v. By writing 3uv times u plus v in terms of s and t, we can now write 3s times t squared plus 1. By rearranging the equation, we have u cubed plus v cubed equals s cubed minus 3s times t squared plus 1. So equation 3 can be written as s cubed minus 3s times t squared plus 1 equals 9 times 337t. Since 3 divides 9 times 337t, and 3 divides 3s times t squared plus 1. So from equation 4a, we know that 3 divides s cubed, thus 3 divides s. Since 3 divides s, so let s equal 3w. W is a positive integer. Equation 4a can be written as 3w all cubed minus 3 times 3w times t squared plus 1 equals 9 times 337t. By simplifying the equation, we can now write 27w cubed minus 9w times t squared plus 1 equals 9 times 337t. We can see that we can divide both sides of the equation by 9. So we can now write 3w cubed minus w times t squared plus 1 equals 337t. We can factorize the left-hand side of the equation, so we can now write w times 3w squared minus t squared minus 1 equals 337t. Hence, w divides 337t. 337 is a prime. T might be or might not be prime. Let T equal m times n. M, n are positive integers. If T is prime, then m equals 1, n equals t. W can be 1, 337, T, n, or 337m. Case 1, W equals 1. Equation 6 can be written as 2 minus t squared equals 337t. By rearranging the equation, we can now write t squared plus 337t minus 2 equals 0, which has no positive integer solutions. Case 2, w equals 337. Equation 6 can be written as 337 times 3 times 337 squared minus t squared minus 1 equals 337t. By simplifying the equation, we can now write 3 times 337 squared minus t squared minus 1 equals t. So t squared plus t minus 3 times 337 squared plus 1 equals 0, which has no positive integer solutions. Case 3, w equals t. Equation 6 can be written as t times 3t squared minus t squared minus 1 equals 337t. 3t squared minus t squared is 2t squared. Since t doesn't equal 0, so 2t squared minus 1 equals 337. So 2t squared equals 338. So t squared equals 169. So t equals 13, as t is a positive integer. So w equals t equals 13. From equation 5, s equals 3w equals 39. From equation 4, we have uv minus 1 equals 169. U plus v equals 39. We can now write u times 39 minus u minus 1 equals 169. By rearranging and simplifying the equation, we can now write u squared minus 39u plus 170 equals 0, which can be written as u minus 34 times u minus 5 equals 0. Thus, u v equals 34, 5, 34. From equations 2, we have x, y equals 2u, 2v equals 68, 10, 10, 68. Case 4, W equals N. Equation 6 can be written as N times 3n squared minus m squared n squared minus 1 equals 337 mn. Since n doesn't equal 0, so 3n squared minus m squared n squared minus 1 equals 337 m. By rearranging and factorizing the equation, we can now write n squared times 3 minus m squared equals 337 m plus 1. Since m, n are positive integers, 3 minus m squared must be greater than or equal to 0. So m squared is less than or equal to 3. M is a positive integer, thus m equals 1. Equation 7 can be written as 2n squared equals 338. So n squared equals 169. So n equals 13. Thus, W equals N equals 13. The next steps are the same as case 3. Case 5, W equals 337 m. Equation 6 can be written as 337 m times 3 times 337 squared times m squared minus m squared n squared minus 1 equals 337 mn. Since m doesn't equal 0, so 3 times 337 squared times m squared minus m squared n squared minus 1 equals n. 3 times 337 squared minus n squared times m squared equals n plus 1. Since m, n are positive integers, so 3 times 337 squared minus n squared is greater than or equal to 0. So n squared is less than or equal to 3 times 337 squared. Thus, n is less than or equal to 337 times root 3. N is less than or equal to 583. From equation 8, we have 3 times 337 squared minus 583 squared times m squared is less than or equal to 583 plus 1. So m squared is less than or equal to 583 plus 1 over 3 times 337 squared minus 583 squared is less than 1. Thus, m is less than 1. Hence, equation 8 has no positive integer solutions. Therefore, x, y equals 68, 10, 10, 68 are the solutions of the given equation. Thank you for watching. Hope you found this video helpful. Please subscribe to this YouTube channel for notification of new videos. See you next time.